In this video, I'd like to talk about Bayes' theorem, which is a way of revising probabilities given new information. And I'm going to use a tree diagram instead of the formulas that are presented in the text. So we start here with a patient who goes to the doctor, and we know that when the doctor performs this test, it has 99% reliability. That is, that 99% of sick people test positive. It does tell them that they're sick. That's what a positive test is. And that 99% of the healthy people test negative. In other words, they're healthy, and it says that they are healthy, that they don't test positive on the test. We also know that 1% of people in the population are sick. So we get a positive test. How likely is it that, if this were me taking the test, that I really am sick? Is it 99%? It turns out that it's not. And the reason is that we have that information down here that only 1% of people in the population are actually sick. So let me go here. Here we have part of the thing. That is that we have people that are sick and people that are healthy. And that if you're sick, there's a 0.99 chance that you get a positive result saying you're sick, and a 1% chance that you get the wrong result, that you're sick, but it says that you don't get a positive result. Similarly, if you are healthy, it will pick that up correctly 99% of the time, and you'll get a negative result that says you're not sick, and a 1% chance that it says you are sick. Even though you are healthy, it will be wrong 1% of the time. So looks like the test is a pretty good one, 99% effective either way. The problem is that only 1% of the population is actually sick and 99% are healthy. So using this tree diagram, you just follow the branches along, sick, positive test, and multiply the branches to get the probability from the whole population that someone is sick and gets a positive test that says they are sick. Then you have people that are sick, but it tells you you're healthy. You don't get the positive result. That will happen to 0.0001, or about 0.01% of the time in the whole population, that you're sick, but it says that you're not. And from the whole population, you have 99% healthy and a 1% chance of it saying you're sick anyway. You multiply across there. And then 99% of the population is healthy, and it gets it correct. It says you have a negative test for this disease. You don't have it, which you don't 98% of the time. But there's the rub. We've already been given that we have a positive test, and that occurs here and here. So we're not talking about the whole population now. We're only talking about people who have a positive result that tells them that they have this illness. And so we're not considering the people that had a negative test, only the people that have the positive test. And you can see from that if we take the people that were positive and sick, which is what we want to know, and put that probability on the top, and on the bottom, that same probability, plus the probability that they had a positive test but they were healthy. And you see here that we end up with 0.5. That is, given that you have this positive result, there's a 50-50 chance that you either have or don't have the result. And the reason that even though that test was effective, that you get this result, is that the distribution of sick and healthy people is different in the whole population. And so that's the base rate, that we start off with 1% sick and 99% healthy. And so that is, I guess, a basic introduction to the Bayes' theorem and how to work them out with the tree diagram, which I personally find a lot simpler to do than working them by formula.